Hello and welcome to ThePrint. I'm Akanksha Mishra and this is Scientifics, where I will be taking you through this week's top science news from across the world. Our first story today is about the Cosmos Map, an international project that has made the largest ever map of our universe with a total of 800,000 galaxies. What's even more interesting is that the Cosmos team has released the data from the James Webb Space Telescope that went into making this map, thus providing open access to every student, researcher, and scientist who wants to access it. The Cosmos map is gigantic in size and scale. For comparison, the other most famous image of our universe is from the Hubble telescope in 2004, which showed around 10,000 galaxies. If we print both these images out, according to one scientist that's involved in the Cosmos project, the Hubble image would be about the size of an A4 size paper, while the JWST image would be a 13-foot by 13-foot mural. It has also challenged a lot of notions about the universe that we had, just in terms of the number of early galaxies that it has been able to capture and photograph. By opening this information up to the public, the Cosmos scientists hope that more and more research can be done about the universe through this mural-like map. The next story is about a study by Oxford Brookes University and Wildlife Friends Foundation in Thailand, which tracked how the number of captive lions in Thailand has increased from 131 in 2018 to 444 in 2024, which marks a 3 times increase in just 6 years. The study also pointed out how this is worrying because of the focus on white lions. So out of 101 cubs born every year in captivity in Thailand, 45% were white lions according to the study. In zoos and parks, these lions are seen as a Thai specialty, but actually they are a result of a recessive gene which is caused by inbreeding. The study talks about how the Wild Animal Preservation and Protection Act of 2019, which was enacted in Thailand, basically has led to more lion possession in private homes and zoos, and it's detrimental to the cause of conservation because it's led to an unregulated increase in captive breeding of these big cats. For our next story, we're covering an interesting paper by the University of Texas, Arlington, which has come with a new way in which we could track the history of environment pollution through museum specimens. These natural history specimens, like preserved birds and fish, can act as time capsules by helping scientists trace pollution trends over the past few years, even hundreds of years. They often store traces of pollutants like metals and soot from the environments that they came from on their skin. So by analyzing feathers, tissues, and even the dust on old bird skins, researchers can detect pollution from eras long before modern monitoring tools existed. One example that the study cited is that a field sparrow from 1906 was coated in black soot from coal burning industries in the US's Rust Belt, while another from 1996 was clean, visually showing how air quality changed over time. The authors of the paper argue that this has opened up a whole new space of research on environment and pollution history. Finally, the last story covers some research by the Johns Hopkins University on cancer, where a group of scientists have shown that they can detect cancer in humans based on the genetic material that's shed by the tumors into the bloodstream. Published in Cancer Discovery Journal, the study says that cancer can be detectable in the bloodstream up to 3 years before diagnosis. This is because this genetic material of tumors shows up in the blood way before the symptoms of cancer actually start appearing. So to conduct the study, the scientists used sensitive sequencing tools and analyzed blood from a large NIH-funded heart study. The scientists found that their multi-cancer early detection (MCED) test could catch cancer-related mutations even years in advance. In one part of the study, 4 out of the 6 people had detectable tumor DNA in samples taken over 3 years before their actual diagnosis. While this is huge promise for early cancer detection, the technology is still under works, and there are certain questions on how to follow this up once a positive result has been detected. That's all we have for you today. Thank you for tuning into ThePrint.